Okay, so we're going to talk a little bit about how you determine if a sequence is a geometric sequence or an arithmetic sequence, or I suppose it could be neither. It could be something else. It could be a different type of sequence completely. So we're going to start off by doing some simple tests that can help you determine what it is. So let's just use this sequence right here. Now remember, if we look at an arithmetic sequence, okay, we have a sub 1, right? A sub 2, etc. And we use D. That's going to be our common difference. A geometric sequence uses a sub 1, a sub 2, so we use the same terms, okay, etc. But now we're going to use R, which is our common ratio. And the key difference between that is this one is addition or subtraction. It could be subtraction. And our common ratio is multiplication. So again, this could be multiplication or division. If we multiply by a fraction, which we haven't talked about yet, it would give us the same thing as if we were dividing. So what we're going to do is we're going to apply both of these. So if we're looking to see if it's the common difference, then we want to apply subtraction. So you take two terms. So the first thing we're going to do is find, here, this will be for an arithmetic test. So we're going to see if this is an arithmetic sequence or not. And the arithmetic sequence test and the geometric sequence test, they're really almost the same. So to find this one, we're going to find D, or at least what might be D. So when we do this first step, we'll find a value that maybe is D. Now, if it's not D, then it could be something, it could be something else completely. It might not be D at all. We don't know what it is. So anyway, kind of rambling here. So what we do is we take any two consecutive terms. I'm going to pick the first two because that'll be easier than these two. So I'm going to take these two consecutive terms and I'm going to subtract the preceding term from the second term. So I'm going to take 12 and I'm going to subtract the term in front of that, which is 4, and I get 8. Now what that tells me is that D might be 8. That's our possibility. It might be 8, it might be something else. So then what we have to do to see if it actually is 8 is we have to check it or test it. So what we have to do now to check it is take another term. It could be 12 to move on here. So we've gone with these two. We could use these two or these two. It doesn't matter. So we'll check with two other terms. And they have to, and instead of saying other, maybe I should say consecutive. They still have to be consecutive. So we can't use 4 and 36. We can use 12 and 36, or 36 and 108, but they have to be consecutive or one after another. So we test it, and if we say 12 plus 8, we see what that is. That gives us 20. But notice our third term is 36. 20 is not equal to 36, which is a 3, or a sub 3. So it is not an arithmetic sequence. Okay? So in other words, it's not D. So 8 is not D. Okay, there's no D in this one. So that's how you test an arithmetic sequence. Now, just because it's not an arithmetic sequence doesn't mean that it could still be a geometric sequence. It can't be both at the same time. It can't be arithmetic and geometric. But so since it's not arithmetic, it might be geometric. So what we'll do is we'll do it almost the same way. We're going to find R, or in other words, what might be R. So once we find the value for R when we do this, we have to remember that it might not be. We might be making a mistake because it might not be a geometric sequence. So what we're going to do is do the same thing we did before. We're going to take any two consecutive terms, but instead of subtracting like we did here, since a geometric sequence has to do with multiplication, we're going to do the opposite of that and divide. So I'm going to take 12 and I'm going to divide by 4. So 12 divided by 4, and that gives us 3. So what that tells us is that if it's a geometric sequence, then R would be equal to 3. We don't know for sure that it's a geometric sequence right now, so we have to check that. So now the next step is we have to check it. And just like here, we're going to use two other consecutive terms. Any two, right? Besides the ones we just used. So check using two different consecutive terms. Okay, so for instance, we can use 36 and 12, or we could use 108 and 36. So if we use 36 divided by 12, okay, that should give us 3. Now notice 3 and 3, oops, I messed up. So actually I made a mistake compared to what I was planning to do, but this is actually another way you could do it. What I meant to do, I just wasn't thinking, is I wanted to take 12 and multiply that by 3, and that should give us the next term. But if you just calculate by dividing each time, you should get 3 each time, and that verifies it. So the amount that you multiply, the number you multiply by each time should be the same. So if you divide repeatedly, then that's what you get. You can do it either way. And if we take 36 and we multiply that by 3, okay, then that should give us 108 also.